the honor, as always, to be today's host of the session. Today we will be having a deep dive, a look into Polkadot, the blockchain network Polkadot, definitely one of the most exciting projects out there, and currently also one of the fastest rising cryptocurrencies. I think it's currently at the 4th place in terms of market cap. So the 4th largest cryptocurrency in terms of market cap. Definitely one of the most interesting and fastest growing projects in the blockchain space. I have the great pleasure of being joined today by Bill Laboon, who will be the expert and today's guest. He is the technical education lead at the Web3 Foundation and will give us an introduction into the technical architecture of Polkadot, its technical features, but obviously also its more macro goals and common goals. Before I hand over to Bill Laboon as our expert, as always, 2 or 3 sentences to Bitkom. So basically, for those who are not familiar with Bitkom, Bitkom is the largest tech association in Europe with over 2,000 member companies. And as you can see here, also quite a broad member network in the blockchain space. We can proudly say that we are the most active and the largest cross-industry blockchain platform, and are joined by members, as you can see, from the tech sector, from the financial industry, more and more young crypto and blockchain startups joining Bitkom, but also obviously beyond. And together with all those member companies, what we try to do is to promote blockchain and crypto technology in Germany. We do that primarily through a lot of political work, so political campaigns, consultations, position papers, meetings, hearings. Apart from that, we are quite active when it comes to the publication of white papers concerning, for example, some new blockchain related innovations such as DeFi or the digital euro on blockchain. And basically our main goal is really to foster the network and to be the place where companies in Germany come together to share knowledge, to share best practices about blockchain, and together to form a thriving blockchain ecosystem in Germany. So for those who are interested, feel free to reach out via my email, which you can find online, or via LinkedIn. And with that said, let's jump into today's topic. As always, in our Bitkom Block web meetings, we will start with a presentation from our expert, Bill Laboon, approximately 25 to 30 minutes long. And afterwards, we will have some time for an open Q&A session, for an open discussion. So feel free to join later on, either here in the Zoom meeting, or also feel free to comment and ask questions on the YouTube live stream. I will try to pick up as many as possible. And with that said, I hand over to Bill Laboon. Bill, thanks again for joining today, for taking the time, and I'm very much looking forward to your presentation.
Yeah, thank you for having me. It's really an honor to be speaking to everyone, and I'm always happy to be talking about Polkadot. Sorry, having trouble sharing my screen for some reason. So just to, of course, it it worked fine a second ago, and now it's not letting me share my screen. So just to give a little bit of background on me, I'm the technical education lead at the Web3 Foundation here in Zug, Switzerland. I've been a part of Web3 Foundation for about 2 years now, working with Polkadot since early 2019. Okay, we're going to try this. So you get to see my whole screen for a second, but let me pop this up. So hopefully everyone can see my introduction to Polkadot slides there. I just a little bit about myself. Before this, I spent 5 years at the University of Pittsburgh teaching computer science. I gave a lot of classes in not just blockchain, but software development, software quality assurance, other things like that. I've written a novel about cryptocurrency. As far as I know, the first science fiction novel that focuses on crypto, and a textbook on software testing. But as I said, I've really moved into the blockchain space specifically over these last few years. So let's talk about what is Polkadot first. It's a heterogeneous multi-chain that connects and secures blockchains with pooled security and interoperability. So this seems like a lot of buzzwords, but we can take this down into all of the details. We can explain what this is. Essentially, Polkadot is a bet against maximalism. The idea is that there is no one single chain that everything should be done on. There are a lot of trade-offs that you can make, right? In terms of all sorts of things, in terms of a UTXO versus an account-based system, or privacy, anonymity on the blockchain, particular features like different kinds of governance, et cetera. But the problem is when you start a blockchain, there are a couple of issues, right? You're trying to make a blockchain on your own. One of which is that trying to secure a blockchain, especially from scratch, can be very difficult, right? Proof of work, we just saw a really huge reorg on Verge just today, like a 200-day reorg. Which is even if you have like a proof of work chain, this can be really difficult to gather the appropriate amount of proof of work. Or if you want a proof of stake chain, well, now you have more direct economic security, which can be difficult to sort of bootstrap. So the idea of Polkadot is that lots of different teams, lots of different projects can make their own blockchains. So we have this, like the scalability and essentially sharding, but it's heterogeneous sharding. These different blockchains are going to have their own different features and make their own trade-offs. And they'll also be interoperable with each other. So it becomes easy to send, not just tokens, but actually like messages and interaction and other data from one blockchain to another. So this is the basic idea behind Polkadot, that we have a sort of a sharded system, but these shards are heterogeneous. They're different, but they can all communicate with each other and share security. So there were a few goals when developing Polkadot, when Gav Wood started it in 2016. So the first was interoperability, as I've already mentioned. We want there to be interaction between blockchains. We want security, right? We want to have a secure chain, and everyone that makes a chain that connects to this should have security. It should be heterogeneous. Different developers are going to want to make different trade-offs in their chain, and different projects are going to choose different chains because of these different trade-offs. And finally, we wanted to have some sort of thought-through governance. We did not want a sort of ad hoc governance structure to emerge. We wanted to have very explicit rules for how the network would evolve. So the basic architecture of the system, you're trying to meet these goals, is a relay chain. If you're familiar with ETH2, this is very similar to the beacon chain, a connector chain that all of these other shards will actually connect to. And here is where the economic security and interoperability sort of take place. Parachains, parallel blockchains, can connect to this relay chain. And thus, and in so doing, they share in the economic security of the entire system. Okay? There's also something that can connect called a parathread, which I will discuss momentarily, but you can think of them as basically a special type of parachain. So individuals or teams can create these different parachains and connect to the relay chain. So parathreads are similar to these parachains, but whereas a parachain stays connected to the relay chain at all times, and thus has full throughput, is able to go very quickly. There's only a limited number of these slots available. So they can end up, and because there's an auction to get onto this, it actually can be, to get a slot, there is an auction. And not everyone will be able to afford this at first. There's also this concept of a para-thread. This is just like a thread in programming, which, when you do multi-threaded programming, sometimes the thread is active, sometimes it's not. So para-threads can still connect to the network. They still have full security, but just less throughput. And they pay on a per block basis. So instead of renting the slot out for a long period of time, they pay for it every time they need to add a block. So a parachain can always downgrade to a para-thread if they don't have a slot. And a para-thread, if they win an auction, can always upgrade to a parachain. From a code perspective, they're essentially the same thing. So if we look at the system as a whole, we have a relay chain. And what produces blocks on this relay chain is something called the active set of validators. So we can see these sort of cylindrical validators. And some of the validators, all of the validators are going to produce blocks on the relay chain. Some additionally will verify that the parachains that they are connected to are following what we call their state transition function. That is, they're following the rules of the blockchain. So when a parachain gets a parachain slot and connects to the relay chain, a rules written in WASM of how the blockchain is supposed to operate and how it will be changed and upgraded in the future is sort of vouchsafed to the validators, right? We go to the relay chain and say, this is how this parachain is going to work, and this is what a valid transaction looks like on this parachain. And a certain type of node called a collator on these parachains, you can think of them as like mini validators or mini miners. They're going to collect transactions and produce blocks on the parachain, and then send a proof to the relay chain that the parachain is following these rules. And since they put the rules up in the first place onto the parachain, then onto the relay chain, then the relay chain can always verify that the parachains are actually doing what they need to do. So you can see there's also a para-thread pool. So these different para-threads, even if they don't have a slot, can always connect. They can win a per block auction and connect and prove that they are still following the rules. And any of these para-threads or parachains can send messages to each other. We even have the concept of bridges to other external blockchains. So they sort of act as virtual parachains. So we have these bridges people are working on them for Bitcoin, for Ethereum, for Hyperledger, and for a few others. So from the point of view of the network, these are just virtual parachains. And this can be a para-thread or a parachain. So that's very, very high level what the architecture of the system is. I want to next go into how this economic security on the relay chain is provided. And that's through something called nominated proof of stake. So Polkadot is a proof of stake system. So there's no mining, there's no proof of work, and there's no proof of authority. Nobody has any sort of Genesis block given right to produce blocks. The only way to produce blocks is to be a validator. And there is a set, anyone can apply to be a validator. You can signal your intention to be a validator, but only the highest staked ones will be a part of the active set, which are those validators that can actually produce blocks. So if you become part of the active set, you or people who believe in you, nominators, bond enough stake or dots to get into the top N slots. So this N is currently 297. We're looking to increase it to 397 through a governance act that should be going up for vote in about a week and a half. At that point, once you have a validator that's in the active set, then it can produce blocks. It can verify that the parachains that are connected to it are following the rules. And in return, they get staking rewards. So just like really, there are any other proof of stake system, people take part in it because they're going to get some rewards back. Here, both the validator itself as well as the nominators, people who sort of trust these validators, will get staking rewards in proportion to how much they've staked. So this is called nominated proof of stake, which means validators can validate with minimal stake on their own. But nominators and validators can be punished through slashing if they do perform infractions. So this could be something as simple as going offline. Now this only comes into effect if a lot of validators go offline. If a single one or just two go off in the same 24-hour period, there's no slashing. This only comes into effect if it's at least 10% of the validators going offline, because that could signal an attack. Or equivocating, if they try to say that two blocks in the same slot are both valid, that also can result in slashing. And as a nominator, part of your job is to ensure that you select good validators, because you also can get slashed for their misbehavior. All of the validators that get into the active set share essentially equal rewards. There is a probabilistic component to this, but over the long run, it's relatively minor. So as long as you get into the active set, it doesn't matter if there are 10 million DOT behind you or 2 million, then you are going to get approximately equal rewards. But conversely, the slashing increases, the amount of slashing increases as the number of validators engaged in an offense increase. So if one validator equivocates, that's a very, very small 0.001% slash or 0.01% slash. But if 20% of validators all perform an equivocation, if they try to say that two blocks are both valid in the same slot, then this would be a very large slash. So these two together really help, these two factors together really help to minimize large groups of people validator. We're using the same, having lots of validators under the control of one entity. This helps to decentralize the network because if you have 50 validators all under the control of some entity, it's very easy for some failure, right? If they all go offline at once, that means slashing. Whereas if you're nominating someone who, an entity that only runs a single validator, then if there is a problem, then your slash is likely to be very, very minor. So there's built-in, like from a game theory perspective, there's built-in benefits to this decentralization, to nominating validators that aren't part of like large groups of validators, because we see this in a lot of POS systems where you have a very few number of validators or block producers or whatever that can sort of dictate the terms of the network. And so we're working on increasing the number of validators as well as having these built-in incentives to pick decentralized and like small groups of validators instead of larger groups. So just to give a really high level example here of how it would work, we have some nominators and they do approval voting of which validators they trust. We expect that if you are a nominator, you are going to do some research into the validators. So we see here 4 nominators and 5 validators. Again, this is a much smaller number than we really have on the network. And each nominator decides, I would trust this validator or this validator. You're allowed to pick up to 16. And there's then an election using an algorithm called fragment, which I don't have time to go into, but the idea is that it tries to come up with the best mapping between nominators and validators. Under some certain, to provide as much representation as possible. So here we can see nominator 1 selected 1 validator. Generally, you will only have 1 active validator in an era. We do this to minimize the mapping because it all has to fit in a single block. Whereas nominators 3 and 4 both nominated validator D. So validator A is now going to share their staking rewards with nominator 1. Validator D will share with nominators 3 and 4. Nominator 2, because they only nominated validator B and validator B did not get in the active set, will not get any rewards. So this is one of the reasons why you're allowed to pick up to 16 validators, to make sure that at least one of them gets into the active set, and thus you get rewards. So after this occurs, this election occurs once every 24 hours on Polkadot. We have some validators in the active set, and they are going to receive transactions not just from the relay chain, but also from the collators on all of these parachains that are connecting to different validators, and produce blocks on the relay chain that show the state transition both of the relay chain and the proofs that all of the parachains are in fact following the rules that they defined when they first joined the network. So if a collator tries to send a message that, hey, on this parachain, somebody with 5 foo coins sent 100 foo coins, then the validators that it's connected to can say, this is invalid, we're not going to trust you, we're not going to add this on to the network. After each era, then staking rewards are distributed proportionally to the nominators. So again, from a nominator's perspective, this is proportional to the amount of stake that you have. So you can see that nominator 1 had 500 dots that he nominated validator A with, and so he gets 5 dots back, whereas nominator 3, who did 800 dots, gets 8 dots back. And nominator 2, unfortunately, gets no rewards because they didn't nominate anyone in this era. Okay, so that's how the network, the relay chain works, the validators and collators. And you may say, well, why should I be a parachain? What's the point of all of this? Why don't I just go and make my own blockchain? Even if I use the tools, right? So we'll talk about Substrate later, the tools to make a blockchain. Why would I be a part of the network? And I already mentioned this a little bit earlier. There are 2 reasons, and that's shared security and interoperability. So any chain that is connected to the relay chain shares in the security of all chains in the network. So right now, I should have looked this up because the number varies, excuse me, but there's about 62 million DOT that are staked on the Polkadot network. It might be a little bit more or a little bit less than that right now. So in order to perform an attack on this network, then you would have to have at least at a very minimum, just to cause disruptions, like 1/3 of that in DOT, which would be a very expensive proposition. And by joining the Polkadot network, you sort of get that, I don't want to say for free, right? Because there's always work involved in software development to do things. But once you join that, then once you join the Polkadot network, then you're getting that security for your chain as well. Since you are explaining, right, when you first join, what the rules are for your system, and the relay chain, which is protected by this large number of dots in terms of security, is going to ensure that your system is operating correctly, and that even if there is some problem, if there is an attack on your network, that it will be refused, right? Any of these attacks will be refused by the relay chain. So the second capability that you get by joining the Polkadot network is interoperability. And that's done through something called XCMP, cross-chain message passing. And this guarantees the delivery of messages between parachains. And these messages could be simple value transfers or contract calls, or really any kind of message or data that you want to send from one network to another. So full XCMP will not put messages on the relay chain. The relay chain just coordinates this. The current version that we have, XCMP Lite or horizontal relay message passing, does in fact put messages directly on the relay chain. So if you put a message on the relay chain, another chain can look into it. But just so you know, this is something that will be changing in the future, probably around summer. So we can see here how this operates, right? Full XCMP, that there's a sort of a gossip protocol amongst all the collators on the different parachains, but they're verifying like the message queues on the relay chain. So they can verify that a message has in fact gotten to one parachain or another. And in a worst case scenario, the relay chain will pick it up. If there's just been no way after a certain amount of time, the message has not been gossiped from parachain A to parachain B, then the relay chain will pick it up. So how do you become a parachain? And that's through a parachain auction. So every 2 weeks on Polkadot, a new slot opens up for a parachain, and there's what's called a candle auction. So this is an auction where the exact end date is unknown. So it's actually determined retroactively from a blockchain perspective. And then the DOT are locked for that period. So while you have this slot, you don't pay. These DOT aren't gone. They're just locked. So they're not sent anywhere. They're kept in the user's account. They're just non-transferable and non-stakeable. So this differs from something like an ICO. You're not paying some network. You're just locking your DOT for the amount of time that you have that slot. Now, you as a project may not have enough DOT to compete for a parachain slot, but your users may want you to have one. And so you actually can do it in an automated and trustless way, have your users decide to help you join this parachain slot. And you may give them rewards such as tokens in order to incentivize that. And once again, the relay chain runtime handles this. They don't have to trust you at all. The DOTs never leave their account. They just get locked if you get the parachain slot. These parachain slots last for up to 2 years, but they're biddable in 6-month time slots. And if the slot expires or you don't get a slot in the first place, you can always become a parathread where you pay as you go. You pay on a per block basis, or even a solo chain. You may decide that you want to keep running your blockchain, but you don't want to interact with Polkadot anymore. That's all perfectly valid. You can always try coming back later. So this brings me to a really common misconception I hear about Polkadot, that any time that I'm going to try to do something on Polkadot, I have to win a slot auction. And this is only true for parachains. It's only true if you want to build your own blockchain. Most projects are not going to need their own parachain. We see this on Ethereum, that or whatever, Tron or Cardano or Tezos. Most projects are going to be at the smart contract level. And there are a lot of different blockchains that let you run parachains that let you run smart contracts. So if you want to write an Ink smart contract or a Solidity smart contract, you can do that on one of the parachains. You don't need to win an auction for every single project. It's only for these sort of base layer parachains. So these parachains can have their own different kinds of consensus models. And in fact, we have seen potential parachains that have used very similar proof of work systems, proof of stake systems. We've seen some like Kulupu that use proof of work. We can have proof of authority. I want to talk briefly about the consensus model used on the relay chain. But again, as long as your parachain, when it joins the relay chain, specifies what its consensus model is, what its state transition function is, then it can use whatever consensus you want. So this particular consensus is sort of the built-in default, since it's what the relay chain uses, but different parachains may want to use different consensus models. So there's sort of a conflict or a tension, right, between safety and liveness in blockchains. And so you see some like Bitcoin that have this probabilistic finality that really focus on liveness all the time. Other mechanisms like Tendermint have provable finality, where we can verify that this was in fact the final block, but have vulnerability of stalling. So Polkadot actually has a hybrid consensus. So block construction is divorced from finalization. So block production can always occur, but of course you may have potential chain splits or reorgs. And we have a separate finality gadget that runs on top of this. So this block production mechanism is called BABE, Blind Assignment for Blockchain Extension. It's very similar to Ouroboros that Cardano uses, where validators randomly select themselves to produce blocks using a VRF, a verifiable random function. And then Grandpa, this second protocol that finalizes the block separately. So if there is some sort of issue with finalization, then block production can always continue and finalization can actually catch up once it needs to. So for instance, if there's some sort of dispute, Parachain is constantly putting bad proofs trying to do bad proofs on the relay chain, finality may lag behind for a while, but block production can continue and we'll always have that approximately 6-second block production time. And then finalization will catch up later. So we sort of have here, you may have conflicting chains in using BABE. You may not have a canonical chain yet, but once Grandpa has finalized things, then it is there's provable finality on those blocks. One other thing I wanted to discuss in terms of things we wanted to accomplish was thought through governance. So Polkadot nodes have relatively simple software. I think of it as almost like a virtual machine that runs a blob of WASM bytecode. And this bytecode, like the actual rules for the relay chain, and this is similar to the rules for parachains, is just a bunch of bytecode. It's WASM, and it's stored on the blockchain, and it's modifiable via the blockchain. So there are some other systems that use this, like Tezos, where any parameter of the blockchain really, including the core code, can be updated and done in a trustless manner, because you can vote on, like, is this the code we're going to start running at block number X? And governance determines how we allow that to happen. So just sort of example here, I didn't actually make this proposal, but just a sort of a pretend proposal where we're going to do a bounty for something from the treasury. So you can see, that it's just like sort of calling a function. If you're familiar with object-oriented programming, you can think of a treasury as a class, and then propose bounty as a function that can be called with value and description as arguments. So there were a few goals of this. We wanted to have really powerful governance that allowed you to make good decisions, was secure, was coherent, and scalable. But it really wanted to make sure we preserve decentralized qualities while doing all of this. So the main rule of governance in our system is that all changes to the protocol must be agreed upon by stake-weighted referendum. So any change to the network can always be countermanded if 50% plus one of the stake argues against it, votes against it. You need a majority of those who voted, actually a supermajority if it's less than full voting, to actually make any changes to the network. But we see in actuality that there's actually very little turnout. So, and this isn't just on Polkadot, right? We see on other networks that on-chain governance, we see response rates around 1 or 2% tops. The highest referendum we actually saw on Polkadot was in the low 20s for the redenomination in August of 2020. So in order to provide voice to these passive stakeholders that don't vote in every proposal, we have the Polkadot Council. So they're elected by DOT holders. There are 13 members, and they have certain powers. They can propose things that are a little bit easier to pass. But again, these just we have something called adaptive quorum biasing, where you don't need a supermajority to pass if something comes from the council. However, their powers are still rather limited. Like, they can't just change the network on their own. Anything they do still has to be put up as a referendum to the stakeholders of the network. There's also the technical committee. So this is another group that helps represent the engineering side. And this is for anyone, any group that has produced a Polkadot runtime can be voted on by the Polkadot Council to the technical committee. And all the technical committee can do, they have, again, very limited power, is say, this is an emergency referenda. We need a shorter time of voting before it's enacted. And so if they agree that, hey, here is a proposal that needs to be enacted quickly, they can fast track it. So we don't have to go into the details of exactly how governance works, but the basic idea here is that anyone, the public or the council, can propose propose something that becomes a referendum. It gets tabled, people can vote on it. So all of this is done using something called substrate. So parachains and the relay chain are built with a framework called substrate. Now, you don't need to use substrate. As long as you're following the rules of the network, you can write in whatever software you want. And there are actually several different groups working on this in different languages, since substrate is written in Rust. But substrate, I like to think of as Ruby on Rails for blockchain. It lets you, just like Legos, you can add some additional things. I want account features. I want democracy features. I want a council. I don't want a council. I want smart contracts. I don't want smart contracts. And you can just add these modules in and very easily make your own chain. And if you produce a blockchain with substrate, it can automatically become a parachain. It has all the features already built in to connect to the relay chain. So the last major thing I wanted to discuss is Kusama. So Polkadot is our mainnet, and we have several test nets like Rococo and West End. However, we also have something which is kind of unique, which is a canary network called Kusama. So Kusama was an early release of Polkadot, and it's meant to be a real blockchain. Again, it is not a test net. However, it is much more experimental. So we, at Parity, at Web3, different parachains can connect to this network and see what happens in a real economic environment, as opposed to a test net, right? Where there's going to be less chance of somebody trying to break it because there's nothing, right? There's nothing for them. It's a test net. But Kusama tokens have real economic value, and some projects may decide only to go on Kusama. Others may try to go on Kusama first, and then once they've made sure that everything works, work on Polkadot. We see this with runtimes too. So we first bring new runtimes to Kusama, and then after seeing that they're working well in Kusama, bringing them to Polkadot. So using Kusama, you should expect chaos. We see that more things can go wrong with Kusama because we're starting out, right, with Kusama. We're seeing what happens first there. So that is, again, a very high level overview of Polkadot. I'm happy to talk more in depth about any of these things that happened to interest you. And I have a couple of different places for more information. You can always follow me on Twitter. I do a daily digest of what's happening in the Polkadot ecosystem there. We have the Polkadot Wiki, which has hundreds of pages worth of information on Polkadot. We have various crowdcasts at Crowdcast. And of course, Polkadot.network and Web3.foundation if you're interested in the network itself or hearing more about what we do here at Web3 Foundation. So that is all that I have in terms of presentation. But as I mentioned, I am happy to answer any questions that we have.
Great. Thank you very much, Bill, for this very interesting insights and introduction into the world of Polkadot. The complex and very exciting world of Polkadot. I would say let's directly jump into the Q&A and open discussion session. Are there any questions or comments here from the people online in the Zoom meeting? feel free to just unmute yourself and jump in.
Okay, I have a question. Hi, Manuel Achuguerro here. I still didn't understand exactly what's then the real benefit for using Kusama instead of the official Polkadot network, because in the end they are both for real. So it's like if something goes wrong in Kusama, it also has real financial implications.
Yeah, so I like to think of it as somewhere between a test net and the full main net, this canary network. So there are differences. So first, it's much cheaper to do things on Kusama. And so we see that to become a validator, it is much cheaper on Kusama. Things happen faster. So votes are much quicker. We have council gets changed out more often. Errors occur about 4 times as fast, right? So run times go there first. So if you want to use the newest features of something, then you would want to deploy to Kusama. So we do see, there are some differences. It's not exactly the same code, but I would say the really big difference here, is sort of a cultural thing. Kusama, I think of as the cyberpunk network, right? Where we try new and cool things, and if you rely on those, and you want to try sort of the cutting edge, then and you're not as concerned about stability, right? And security, right? Because things, obviously we test stuff out on the test nets first, but we bring new features, including parachains, to Kusama first, then you're going to want to use Kusama. And again, the other thing is expenses, right? So we see on Kusama, we have more validators, right? It's easier to get into the active validator set. It's the lowest, the minimal stake on those is like 5,500, maybe 6,000 Kusama, as opposed to about 2 million DOT on the on Polkadot mainnet. We assume that parachain slots will be very similar, right? There will be more available. We'll stretch the limits of things a little bit more on Kusama. And so for some networks, if some projects, that's perfectly reasonable. If you have a gaming chain, for instance, you may say like, well, okay, I'm willing to take a little bit of risk on this. Whereas if you're running a DeFi chain or a supply chain management chain or something that you want to be extremely secure about, then you would probably want to run that on Polkadot mainnet. And some projects are actually running on both. So Akala, for instance, has already said they're going to run Karura, which is their Kusama version, first on Kusama, and then bring out Akala mainnet on the Polkadot mainnet. So there are some pluses and minuses, benefits and drawbacks to each of them. They're not exactly the same. Does that answer your question?
Yeah, but then what I then understand from that is that then it's like your nightly build, so to say. So there you can have features that you don't have then in the Polkadot chain. So means if you develop your system for running Kusama, it could be that whenever you want to move to Polkadot, then you're using features that are not yet available there.
Yes, so that's possible. And there are some features that may never go to Polkadot. So one thing I think that's actually kind of interesting and fun about Kusama is the Kusama Society, and this is or Kappa Sigma Mu. So this society palette you may have seen, you get a tattoo of Kusama and you prove it on chain that it has like the hash of the index of the previous person, right? So you get a link back. Then you can then actually get the burned treasury funds from Kusama. So this is kind of like a cool, fun feature, this palette on Kusama that will in all likelihood never get onto Polkadot mainnet. But if you want to have a chain that is just for people that belong to Kappa Sigma Mu, then you couldn't have that on Polkadot, right? You depend on that. Social recovery is something that's being tested out on Kusama that's not on Polkadot, where you can have recovery from other accounts of your account. So So again, yeah, it is kind of like if you're used to building on Rust, like building with nightly, right? These features that you may depend upon may not be on Polkadot or may not be there yet. So you do need to keep in mind that you can't depend upon those, right? If you are you want to eventually build, for Polkadot. But on the other hand, you could just make sure that you don't use, it's very easy to check. All of this code is online. It's all open source. It's all, in fact, on the blockchain. You can just view and see what the features are. You can just make sure that you don't use those features, just like if you're building in nightly and you don't use whatever new macros or whatever are in the features are in the nightly, and to make sure that you can move up. And we also have test nets, right, that are built like Polkadot. So West End is meant to be as similar to the Polkadot mainnet as possible. So you can run something on Kusama, take that same code, verify that it works on West End before moving it to Polkadot.
Right. Thank you very much.
Yep.
Any other questions? Otherwise, I'd have some. So, Bill, what I would like to understand is what is the status quo actually right now? I mean, I understood the mainnet is live. How many parachains exist? Is this kind of auction and bidding for parachains? Is this already an ongoing process? Is this kind of governing council already live? Where are we at right now?
Yeah, so right, so the mainnet has been live since August 2020. Kusama has been live in a full-featured version since November of 2019. Governance was activated on the mainnet shortly after launch, and obviously it's been on Kusama for much longer. The staking and validator system, that's all been live and working. Consensus has been working. Parachains are still on testnet only, so they are getting rolled out in the very near future. We have had multiple parachains connecting to the Rococo testnet, and we have already made some announcements, although there's no specific dates. Especially because we want to make sure that people have time to unbond their tokens in order to participate in these parachain auctions. But in the near future, we should be preparing for parachain rollouts on Kusama. Once parachains roll out on Kusama, which again should be in the very near future, it's already working on Rococo testnet, and again, you can check out the parachains that are connected using the Polkadot.js Explorer and look at what's happening on them. Then probably within 4 to 6 weeks after that, there will be a proposal to roll that out to these parachains out to Polkadot mainnet. So again, nothing happens without stake-weighted referendum. So in order to activate parachains, we need a vote essentially on Kusama to activate these, to add this code into it. And then after that, we need stakeholders on Polkadot to vote parachains to be activated there. But again, working on testnet, really parachains and XCMP Lite are sort of the last of the major features that need to be added. And again, we've already started releasing notes about how the parachain auctions will work. So you should expect to hear much more about that in the very near future.
And how many parachains will there be in the end? What is the goal? Is that comparable with the ETH2 shares, or how does that look like?
So the goal right now is to go up to 100 parachains over the course of approximately 2 years. So every 2 weeks or so, an additional like a regular parachain, for lack of a better word, like an actual external parachain will be added. We also plan on adding what we call some common good parachains. So these are like system level parachains and bridges, things that are good for the entire network as opposed to individual projects. So the goal is to go up to 1,000 validators on the mainnet and 100 of these parachains. So obviously, there's going to be like a slow progress. If we notice that there are, empirically, we figure out that there are some problems with having that many, then we may slow it down, or if we may increase it. That's for the medium term, like over the next few years, our goal is to get up to 100 parachains. In the much larger picture, right? But we're talking, very far down the line. We have this idea of nested relay chains or hierarchical relay chains, where we can have parachains that act as their own relay chains. And then you would be able to have many, many more, right? Thousands of parachains connected indirectly to the relay chain, because they would connect to a relay chain that acted as a parachain for the relay chain, if that makes sense. Like, a relay chain connected to a relay chain, etc. But that's that's really far in the future. That's still in the research phase. So there's no theoretical reason that we know of that can't be done. But from an engineering perspective, obviously that is much more difficult than a relay chain with just parachains connecting directly to it. But in the medium,
it sounds complex, very complex.
It is. It gets very complicated. But yeah, in the medium term, we're looking at about 100 parachains.
Okay, cool. And last question, maybe from my side, how do smart contracts look like within Polkadot? Is that comparable, similar to Ethereum smart contracts?
So yes and no. So the Polkadot relay chain itself is by design very simple and is meant just for providing security and helping interoperate. However, all of these individual parachains can have their own smart contract systems, and there are some smart contract systems. So there's one we're working on called Canvas, which uses the Ink programming language, which is based on Rust. There are also at least there are at least two parachains, Edgeware and Moonbeam, that are looking to be as Ethereum-like as possible. So you can use Solidity, you could use Viper. They have EVM. You can use Truffle with them. The only difference is going to be that obviously below the surface, they're going to have faster block times and cheaper transactions. But from a development perspective, should be essentially the same. In fact, Bruno Schwartz, who is one of our other technical educators, did a crowdcast on this of using your regular Ethereum tools to develop on Moonbeam. And there are other chains that are they're using EVM. There is an EVM module, Ethereum Virtual Machine module, that you can plug in. So Akala, for instance, allows you to interact with their DeFi primitives on their chain, but using an EVM. So you could write some Solidity code and interact with their DeFi primitives. So obviously it's a little bit different than Ethereum because they've got different primitives, but you can still use Solidity to interact with it. And then there are other chains like Fala, which has confidential smart contracts. They're actually doing it in having smart contracts in a way that you can verify that they work without actually seeing, and that they're doing what they're doing without seeing how people interact with them. So different, really, Polkadot is sort of pushing this out to the edges, right? To different parachains are going to have different ways of having smart contract development, all the way from let's do it as Ethereum-like as possible to like let's do some really strange stuff or use like non-EVM systems for the smart contracts. So really, again, that's part of the joy of Polkadot, is that it's heterogeneous. There are all sorts of different ways that these different parachains are going to face implement smart contracts.
Yeah, it sounds like Polkadot is really, Polkadot's goal is really to intertwine all those different blockchains already existing and create interoperability between them.
A good way.
Or do you see any maybe also a more provocative question? Do you see any long-term competition with ETH2 there for the relay chain, or? So
we don't really see other blockchains, I would say, as competition, right? That our goal is to be a layer 0, as opposed to a layer 1, right? That we have bridges to all sorts of other blockchains and can interact with these other blockchains. Gav Wood had this great saying that Polkadot is a bet against blockchain maximalism. That the idea of Polkadot is that there are going to be other chains out there. We should work with them. And in fact, the world just gets better, right? If we have all of these different blockchains that can all interoperate with each other. So it's just like the internet. We have Macs, we have PCs, we have people with Linux, we have people with BSD, right, or whatever, and they can all interact with each other. So that's sort of the goal of Polkadot, is that there are going to be lots of different blockchains out there, and we should do our best to interoperate with them and help people create their own blockchains.
Great. Last chance for all our participants. Are there any last questions or comments? No questions for now. So I would say, Bill, it's almost 5 p.m. Thank you very much again for taking the time for those great insights into the world of Polkadot. I think it's definitely something that we will also, as an association, look closer into in the future. And yeah, looking forward maybe to future conversations with you.
Definitely.
Once maybe more parachains are live, and once the whole complex ecosystem is more live. At least personally speaking, I can say that it's definitely one of the most exciting projects out there.
Yeah, thank you. It's been a pleasure speaking, and yeah, I agree. I think it's a very exciting project, and I'm always interested. I'm always excited to see what is happening every day in it.
Great. So thanks again, Bill. Thanks everyone for joining, and have a good evening, everyone. Bye bye.